Welcome, everybody. My name is Brian McLogan, and tonight we're going to do something a little bit different as far as on the live stream. I am just basically just opening up for a Q&A. So this is the last week in our school where we are going to kind of work on the end of our last test before we get into spring break. So I really don't have any homework or quizzes that I'm going to be covering. So what I wanted to do in this case was just kind of open up a Q&A for you guys, and therefore you guys can bring in some questions. So I did kind of post this in there to kind of see if there's any questions you guys have. Obviously what I'll be doing is checking out through the live stream. So I see you, Shaggy, Fortnite, Diego, good to see you guys out there. Isaiah, I'm glad for you to come along. So I do have one question on here. And again, guys, I do not have anything planned for this live stream. So again, compared to, what we usually done where I'll do my homework assignment and blah, 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 or go through a quiz and then, kind of go through it. And I don't really get to your questions. I am basically here for you guys, for this, at least the next 25, 30 minutes. So if you guys have any questions, anything you guys are covering in their classes, this is a format that I would like to kind of investigate more, a little bit more, for maybe possibly looking into next year as well. Because, as of this year, it was just a lot to do all those live streams for pre-calculus. But one thing I've always kind of missed is obviously getting to a lot of the questions. So, I want to make sure I can also help you guys out as best I can. I know obviously you guys watch a lot of, the videos and get help that way, but sometimes you just have a problem that, my video or something else doesn't really connect with. So that's what I wanted to kind of do with this stream a little bit different here. So if you guys, again, just post your chat. What I'll do is I'll just kind of get a nice little list. And then once I kind of have enough problems that I feel will take us long, then I'll just kind of close down the inquiries and we will just kind of get into the math. So I have one question right here that was submitted. And then to say, how do you solve? I don't see an equation for yours, so I'm not sure what you're asking me to solve. I do see an inequality for you on that for the logarithm, but let me just go and see if I write it and you can maybe confirm it for me. So I have 1/2 log base 3 of x squared minus 6x. That's supposed to be a 6x plus 9. And then plus log base 3 of 9 is less than, oh, my writing is all good. All bad. Okay, so I can go and cover that with the logarithms. Sorry, let me just check. We'll cover. All right. Let's see here. Then I said I have a test on special right triangles, 45, 45, 30, 60, 90. Andre, yes, I can talk about special right triangles. So we'll do the special right triangles is kind of like a special right triangles. Let's go like with tips. Okay. Ryan, are you in? Hi, I'm from India. Well, good to see you. Gaming Zone, you're better than my actual teacher. Well, I'm just happy to be there, and hopefully, just some learning going on. That is awesome. Solve the equation x to the 5th. That doesn't seem like very much fun. X to the 5th minus 32i. Well, I'm not having a calculator, and that would be a complex, so LP, I'm sorry, I'm not going to be able to solve this, at least as far as getting any more further imaginary solutions. You could take the 5th root of that, which would 5th root of 32, which would be I, and then, but I'm not sure. Haven't covered as far as the 5th root of I. It's been a while. It's not really coming right up to my head. So unfortunately, I'm just going to bypass it, or at least not say that that's something I would be able to at least cover. But I know you can definitely take the 5th root of 32, which is going to be 2, and that I'd have to think about I being the 5th root of I. So maybe it'll come to me after my stream. Should I get a hug? Sure, man. Little virtual hug. I need help with factoring polynomials. I can just kind of cover a little bit. I'm sure everybody just loves factoring. So we can kind of cover that, polynomials. All right, rational inequalities. Oh, geez, it's been a while since I did anything. Fusion, exponential functions. Again, guys, I mean, these are generic topics. If you have anything like particular that I can, or like specific I can go over, it'd be much easier for me to kind of go over them. But I can talk about rational inequalities and rational functions. So let's go over rational, I'm just going to say like equations, and since you guys don't have anything specific, I'll say rational equations, inequalities, tips. All right, factoring polynomials, we got that. Exponential, I'll go over exponential tips. I'm not really sure, again, what you want from exponential, so if Chloe, if you can maybe like elaborate on exponential functions, because I can just go over, I'll just cover graphing. But if you want to, if you are looking for something else than that, then just let me know. How to get points from an equation. Sareem, I'm not really sure what exactly you'd want me to address, so I'm going to have to kind of bypass over there. Please graph a parabola. Let me kind of know if you're looking into vertex form or standard form. Exponential functions. Again, Chloe, just what do you want me to do on exponential functions? Can you explain a word problem? Jose, I'm not going to get into. I'd love to do a word problem on like maximizing and like the profit and all that. It's just going to be like kind of too much for a live stream for on that. And then obviously just the whole like writing the equation and stuff like that. Basically, I can talk about the maximizing the profit and kind of what to do, because actually, yeah, I'm not going to go through a word problem, but I'll kind of at least tell you at the maximizing the profit on a quadratic functions. Any pre-calculus, I need help with factoring, we'll do that. And behavior, we can talk about that. I'll do a little review on M behavior, review for a test. Well, I have a lot of tests. Trigonometric identities, verification. Geez, there's a lot. Can you explain? Ooh, hey, Oliver, $1 super chat. Well, thank you very much, Oliver. I appreciate that. I wrote the problem down. Created sine of x equals smiley face. All right. Oh, geez. Man, maybe this was a bad idea for this open thing. I'm going to need somebody to like pull out questions from here. Hey, Monty's dad. What's up, Wyatt? Glad to have you on in the chat. Monty's dad. Awesome. Dago. Man, everything's going so quick. All right. So math topics. Can you qualify someone as a teacher of the All right. I want the points for 2xy. Okay. Well, I can help. Let's do this. Graph for the points of 2x plus y equals 4. All right, guys, I am quickly getting to my limit. I mean, it's been 10 minutes in, and I already have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess maybe I'll do the next one. Andrea will touch that on that. Enter answer using interval notation. Solve the rational inequality. I'm not sure what the rational inequality is. Fusion. I'm not understanding. Is that 8 minus? I'm not sure. I'm not understanding that notation. Chloe, again, if you can explain what your function. I have an exam. I know, but what would you like me to cover on exponential, vertex form, and exponential, please? So I'm assuming vertex. What vertex form of quadratics? I'm not sure. All right. Let's see here. Find the zeros. Okay. I am sorry, guys. I was hoping I would have had some questions. I'm just going to kind of run through this last one here provided by CT, and then if I have some time here, I will come back through some of these questions. but I'm going to have to close this off. Otherwise, I feel like we could basically just keep on going throughout the nighttime of me answering math questions. So obviously, I have been suppressing you guys by covering the stuff in my own classes, and you guys have a lot of questions. So I do appreciate that. It's kind of overwhelming. I was not expecting this much of an onslaught, because usually when I like do my math, you know, my stuff, everybody like asks for questions, and I mean, I would say probably 90% of my streams, I barely answer any questions. But this open one, a lot of people came to answer. So I really do apologize, especially for those of you that maybe even took along, set aside some time to, you know, you had questions. Obviously, this tells me this is something that I might want to look into doing for some future or like some ongoing live streams. So thank you for that, for letting me know about that. That is something I will be planning to possibly do, especially as this year is now kind of winding down for me as far as creating my content. So maybe I can start doing a little bit more open streams for you guys. All right, so let's get on to doing some math. So the first question is, I'm not really actually sure what the question is, but I'm going to apply this, and then Wyatt, if you can maybe clarify this, we're maybe trying to see. Actually, let me see what the question was. Solve. So I'm not sure what to solve, but I'm going to work it out. And then Wyatt, if you have any questions on this, just let me know, or let me know, because I'm not sure what the directions are. So on this first one, it's basically 2x minus 6 times x minus 4. All right, so I am going to show a method to multiply these. So what I'm going to do is I'm going to use the idea of multiplication of rectangles. So if we were going to multiply like a rectangle, you know, 2 times 3, we'd know the area is going to represent, it would be 6, like, you know, length times width equals the space inside the box. Now, in this case, we have polynomials, which is a little bit more abstract of an idea. But again, we're multiplying. And when you think about multiplying, you know, two numbers, like you can think about it as identifying the area. Well, that's exactly what is happening here. It's just a little bit more abstract because we have this unknown variable x. So what we're going to do in this case is we're going to create another box. And basically what we're going to do is we're going to represent these just like 2 and 3. Right? These are going to be represented as the sides of the box. So we can say one side of the box would be 2x minus 6, and the other side of the box is x minus 4. Right? Because that's really all we're doing. We're multiplying this binomial times this binomial. And in reality, what they are giving you is the area of the box, just like it would be for 2 times 3. Now, obviously, since I have these as binomials, that means they're separated by, you can see, subtraction. Therefore, I'm going to separate the areas, because obviously, if I find the area of each one of these boxes, then I can find the area of the box. And again, same kind of thing here real quick. I could break this up. Let's see, I could break this up into 1 plus 1, and I could do 2 plus 1. Like, isn't 1 plus 1 is 2, and 2 plus 1 is 3? Now, if you just do, like, why would we do that? But again, it's just the idea for you to understand how this makes sense. So again, if you think about this, if you just find the area of this box, 1 times 2 is 2. 1 times 1 is 1. 2 times 1 is 2. And 1 times 1, which is length times width, is 1. Now, the area, everything added up in this box is 4, 5, 6. It's the same as that box. So that's all we're really doing is we're just resegmenting the box. So 2x times x is going to be 2x squared. 2x times negative 4 is a negative 8x. X times negative 6 is a negative 6x, and negative 6 times negative 4 is a positive 24. Now, the nice thing I like about this as far as the box method is you can see that we have like terms. So our like terms here is the negative 6 and the negative 8. And so therefore, it's just like, you know, 6 apples and 5 apples, you know, and so forth. But we have negative, so it's kind of like owing money. It's like you owe me $6 and you owe me $8, therefore you owe me a total of $14. So therefore, that comes into the final answer of 2x squared minus 14x plus 24. So hopefully that helped you out, Wyatt. If not, let me know, and then I'll be more happy to. It was to solve for x. Okay. So I'm not sure. All right. So to go ahead and solve for x. Now this is a little bit little bit different here. So that's the multiplying portion, how you got that to be true. Solving for x is going to be a little bit different as far as in the context. So basically, we want to solve for x. Typically, we're looking for solving for x when this equation is equal to 0. So basically, if we had the equation 2x squared minus 14x plus 24. Now, this is what we call the factored form. And this would just be the standard form. So if you're given the problem in factored form, that's fine. Typically, we want to go ahead and write it in factored form. And the reason why this is helpful, and hopefully you see the relationship from standard to factored form and how I went from factored to standard, but now you can write it into this form. Now, this is important because if we are going to, let's do a random problem here. Let's say 7 times x equals 0, right? If I was to say, like, what is x? You would say, well, x is equal to 0, right? X has to equal 0. Well, then if I said, well, what about, yeah, let's do this. What about if I said a times b equals 0? Well, now we don't know which variable is going to equal 0. They both can be equal to 0, or at least one of them has to equal 0. And that's what we call the zero product property, that a is equal to 0 or b is equal to 0. And that has to be true, right? If you're going to have the product of two numbers equal to 0, one of them has to equal 0. They both equal 0, but one of them has to equal 0. So therefore, in this example, what we do is when we have the product equal to 0, it's just like the a and b times 0. And to solve for x, those are the values that is going to make each of those equal to 0. So we just set each factor, which we call it, equal to 0. And now we have linear equations that we can solve. So therefore, I'll just show my work here. Now we can add 6 to both sides. So therefore we have 2x is equal to 6. Divide by 2, divide by 2. X is equal to 3. And then we have plus 4 plus 4. X is now equal to 4. All right, so let me know. Give me a thumbs up if that works. Otherwise, if you have further questions, let me know. I'll be looking out for it. All right, so let's get on to it. And I see you guys are still adding in some questions. I'll try to do my best. I'm going to at least knock out the questions that I initially have here. I'm going to knock out these questions that I initially have here. And then what I'll do is... and then I'll try to answer any other questions you guys possibly have. So hopefully that will get you. But I do apologize. I'm not going to get to everybody's questions. That is for sure. All right. The next one, as far as on the inequality. And let me thinking on here. You could read that as a multiplication. Multiply by 2. I'm actually just going to skip this just because it's been so long since I've done my inequalities. I'll have to come back to it. It's just not something I would have to just go and look at the problem. I'm looking at right now, you're going to want to use the properties of logarithms to at least combine these. You have the 1/2 out in front, and you can get rid of that by multiplying by a 2. And so what I would look into doing is, let's see, you could multiply that and then get you through there. But this is a problem I'd want to just go ahead and take a look at. I don't want to really go through it on a live stream, just because I would figure I'd want to sit a little bit more time working on that one. So I'm going to skip over that one. I apologize if that was something you're holding on to, but I would definitely work into looking at the rules of logarithms to isolate. And the main idea that you want to do is get this down to one logarithm. So you want to get this down to one logarithm by using your properties of logarithms. And again, so a couple tips I'll tell you. Forget about the inequality for right now. Just worry about it as an equation, and then use the properties of logarithms to get it down to one log. So that's your main idea that you're going to want to do. I just don't want to spend a whole bunch of time working through this one example, just because the exact answer is not immediately coming to my head. So I don't want to have to redo a couple different ways to get it right. The next one is special right triangle tips. And as we're going over special right triangles, So as we're going special right triangles, let's see, special right triangles. All right. So yes, I mean, I think it's easier just to really kind of understand like their relationship. Like the 45, 45, 90 triangle, like the nice thing about that is you know that these two opposite, this is an isosceles right triangle, right? You have two opposing angles. So if you have these two are the same, right, these two have to be the same. So the 45, 45, 90, those two sides are the same no matter what they are. And then again, if you get like stuck with this, just remember you can always go back to using Pythagorean theorem. And I think that's like if you wanted a tip here, I would just say like, you know, if you can just remember that, you know, to find your side, you know, the 45, 45, 90, and then if you don't remember this is x times square root of 2, just use the Pythagorean theorem. In the same respect, I always have the short leg and the long leg. I always just say the short leg is like your base. So for an isosceles 45, you keep these two legs are the same, right? So they're the same size, so they're x. And then you can use Pythagorean theorem to find the hypotenuse, or just remember it's x times square root of 2. The 35, 35, the like base that you can use is x as far as for the short leg. The hypotenuse is easy to remember because that's x times square root of 2. And then the long leg is a little bit harder to remember, which is x times square root of 3. But again, if you forget it, just use the Pythagorean theorem. So I would just look at these triangles, you know, 3, 4, 5, 10 times, keep on going over them and over them. And then really the main important thing is, you know, to remember like, all right, to go from short leg to long leg, you multiply by the square root of 2. If I give you the hypotenuse and I want to find the short leg, then you divide by the square root of 2. So you're just using those inverse operations. You know, to go from here to here, you multiply by the square root of 2. But if I give you the hypotenuse and I want to know the leg, then you're going to divide by the square root of 2. So, I mean, I just worked through a lot of practice problems, you know, with that. And, you know, and again, just remember the right triangles. So if you get stuck, try to see if you can use the Pythagorean theorem as a benefit for you. The next one is factoring polynomials. Well, I did do an example here, so let's go ahead and just like work on this one. 2x squared plus 3x minus 7. Two x squared minus 3x plus 7. Was that it? Did I already forget it? Plus 3x minus 7. All right, so plus 3x minus 7. And just want to give you guys a quick little update. Again, I've kind of already picked out some problems for people that were like right here, right when I started my live stream. So I already have 10 questions. I do apologize. I'm not going to be able to get to everybody's answers. I see a lot of questions that have come in, and it's overwhelming for me at this point. So I do apologize, guys. I'm not going to be able to get to all of them. But you guys definitely are giving me good ideas to make sure that I continue doing this so I can answer your questions. And then hopefully I'll come up with a better system so you guys can you know, shoot questions over to me beforehand. So therefore I can make sure I have them addressed, because obviously it's very hard to read them and everything through on the live stream. All right. So let's do another like basic one. So x squared, let's do plus 4x plus 3. All right, so I'm going to do, these are just basically factoring quadratics. But then from factoring quadratics, we can talk more about like polynomials, because I didn't have any exact examples. But the main important thing I want to talk about with the factoring is like when we looked at the multiplying, we looked at the finding the area of a box, right? Well, the factoring is basically like the exact opposite. Like this, when you're trying to factor, basically what you're trying to do is you're trying to rewrite the expression as a product, all right? So here we have an expression which really represents the area, and what we're trying to do is try to see if we can find the side lengths that we can multiply to give us this area. So at least with quadratics, or with quadratic trinomials, what we've recognized over and over is that the product of two binomials gives us a trinomial, or a quadratic, or yeah, that gives us a trinomial typically, or of these quadratic trinomials gives you product of two binomials. So therefore, through a lot of practice of problems, we recognize that the first two terms is always going to give us that first term, and the last term gives us 3. So we know x times x gives us x squareds, and then we just got to think of what two numbers are going to multiply to give us a positive 3. Well, that's positive 3 and positive 3, and negative 3 and negative 3. However, since the middle term is positive, we don't want our two terms to be negative. We want them to be positive. So we can say x plus 3 and x plus 1. And again, we can check our work if we wanted to. Like, You can put that as x plus 3 and x plus 1. And now as you'd go ahead and multiply this, you can see what is happening here. 3x, that becomes 1x, and that becomes 3. And then we have our like terms here, and you get the exact same answer that we came up. So that's the whole idea of factoring. It's basically taking something and then rewriting it as a product. So, and this one's usually like an easy answer. Now, when we have like the a is not equal to 1, that's usually where a lot of students get mixed up. But again, if we understand that this quadratic trinomial is written as a product of binomials, we can kind of simplify this, right? And there are other techniques to do this a little bit easier, or like, you know, not have as much number sense basically. But the idea is the same. We know that the first two terms need to give us 2x and x. So then I'm going to write 2x and x. The last two terms need to multiply to give us negative 7. Well, like 3, 7 is a prime number. So it's either going to be positive 7 and negative 1 or negative 7 and positive 1. Now, I recognize here, did I do that? Wait a minute, what the heck? Oh, did I like write that down wrong? Yeah, I did. That's supposed to be a 24. Plus 24. Hold on a second. What was that? 2x squared plus 3x. That doesn't even make any sense. 2x squared plus 3x minus 7. Okay. 2x squared plus 3x minus 7. All right. So that's how you factor that one. But this one, that one was not factorable. So this one, you can see that actually is not factorable. So 2x squared plus 3x minus 7, I'm not seeing anything that's factorable, because if I multiply by 7, like let's say this is negative 7 and this is positive 1, right? You can see that 2x times x gives you 2x squared, good. 2x times negative 7 is a negative 14. And then you have 1 times x, which is x. Well, even though this gives you negative 7, the middle two terms, when you do 2x times negative 7, that gives you negative 14 plus x, that does not give you a positive 3x. So that one doesn't work. And then the only other option you have here would be 2x minus 7 times x plus 1. And in this case, you can see here again, our middle terms do not add to give us a 3x. So this becomes a negative 2x, and then plus 2x, positive 2x, gives you a negative 5x. So this problem would not be, you would not be able to actually do this by factoring. You'd actually have to use the quadratic formula. So this would be not factorable. So the problem I think that I worked on, or what I was doing, was 2x squared. What do I have? That would be negative 10x plus 24. Okay, 2x squared minus 10x plus 24. So this one, you could factor it out into 2x and x. Now the problem with this one is the positive 24 is, so the positive 24 has a lot of different numbers, right, that are going to add up to it or then multiply to it. So basically we just want to think about, like, you know, there's a lot of different factors, and it really kind of comes down to, you know, playing around with the numbers and just kind of seeing which one really kind of works. And 6 times 4. And then kind of seeing which, playing around with that and kind of see where you can kind of go from there. And obviously, I already have the answer up in there, so I might just cheat and go for it, because I think it was 6 and 4. Yeah, 2x minus 6 and x minus 4. So 2x minus 6 and then x minus 4. And if you see how this works, obviously 2x times x gives you 2x squared. Negative 6 times negative 4 is positive 24. Well, negative 6 times x is going to be a negative 6x, and then that doesn't work. So that was supposed to be 6. That was supposed to be 8, so that's supposed to be a 14x. So I made up this problem wrong. Okay, so I was making up the problem as far as what I was looking for. So negative 10x wouldn't work as well. So hopefully nobody caught this. Would a negative a be set up there. So anyways, let's go and look into what we do with if it's non-factorable. So if it's non-factorable, you're going to have to use the quadratic formula. Now again, it's important to only use the quadratic formula when something is a quadratic. So the zeros is opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so in this problem, we can call our a g2, b is 3, and c is going to be a negative 7. So therefore, x is equal to opposite of 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 7 all over 2 times 2. And then let's do this one more time. So x equals negative 3 plus or minus the square root of 9. And then we have negative 4 times 2 is going to be a negative 8 times a negative 7 is going to be a positive 56 all over 4. And 9 plus 56 is going to be a square root of 65 over 4. So you can see then, obviously you could do factorable across irrational numbers, but I'm not going to get into that. And I kind of just focused a little bit on the factoring, and I didn't really go the way that I wanted to, so I apologize because I was kind of making up some problems. But hopefully you guys at least get the idea and the general idea with the factoring, because again, with polynomials, the only thing really added is, cubic functions, factoring by grouping, or just doing the exact same process with quadratics, but just raising the powers. But the idea is going to be exactly the same. You're looking for, and also factoring out the GCF, looking for what they have in common there. JBook's asking, is this pre-recorded? No, it's not pre-recorded. I'm just going by the fly, see what I can help you guys out with. All right, I am not going to be able to get through all this stuff. All right, so let's just kind of touch on rational equations, guys, because I do apologize. I did not have this much time set aside for this, but I will try to knock out these questions as best as possible here. So we can kind of talk about some tips here. Since I don't really have any problems, and I'll do this one problem at the end, or the last two problems at the end. All right, so let's talk about tips. So rational equations, inequalities, tips. First of all, for the inequalities, just treat it as an equation. The next thing is factor and simplify. If there's one thing I can tell you to do with rational equations, is factor, simplify, like get rid of the fractions. So you can get rid of the fractions, usually by factoring, right? Determining the denominator, dividing into the denominator, or what I like to do, sorry about that, is multiply by the LCD. So make sure you multiply. So you find the common denominator of everything. It doesn't matter if it's a rational equation or an inequality. Just multiply everything by the LCD. That's going to eliminate all the fractions. And then you can go ahead and solve your regular linear equation from there. And then sometimes factoring is going to help you out as well. Exponential equation tips as far as graphing. Again, the exponential equation, y is equal to e to the x. Just remember that generic equation here looks like this. So you're basically just going to, have this y-intercept 0, 1. Make sure you understand the transformations and what they do for the graph. So y is equal to a times e to the x minus, let's do plus c plus d. You could also have a b in there, which would affect the graph. But remember, a does vertically stretch or compress the graph. It also is going to change where the intercept is. Remember, C is going to be shifting the graph left or right. D is shifting the graph up or down. Make sure you remember that the domain is unrestricted. The range is from 0 to infinity because there is a horizontal asymptote at y is equal to 0. And as far as the graphing, the two things I would look into, not graphing, but if you're going to look into solving, is using I forget the things. If you have b to the x and, and then b to the y, then x is equal to y, right? So using that, the one-to-one property for exponentials, or obviously using logarithms to bring that power down. So that's kind of the main thing. I would say there's a lot I could talk about that, but I don't really know specifically what you were looking for. So, Claire, I'm just going to have to working on that. Maximize profit quadratic. So again, if you have a function here that is representing the profit of a business, right, then we're looking for this maximum point, right? Now, if this is a function f of x, and this represents, again, the profit, we're looking for this vertex. So you could use a graphing calculator, but if you don't have a graphing calculator, and this is a quadratic, remember, so that means it's going to be like f of x is equal to ax squared plus bx plus c. Well, then the vertex, remember, is going to be opposite of b divided by 2a. So that is your axis of symmetry, which is x is equal to opposite of b divided by 2a. And so that's the x coordinate, and then the y coordinate is basically you take that value and plug it back into your quadratic. So opposite of v divided by 2a. So we cover this a lot, you know, when it's first in the early stages, but obviously if you have a graphing calculator, you can make that a lot easier. As far as end behavior goes, I mean, I'm just going to go with polynomials. I'm assuming that's what you were asking about as far as on polynomials. So, you know, I like to look at this as kind of 4 quadrants. Basically, let's do this in blue. What we're looking for is the degree. And remember, the degree is the highest power of the polynomial. So it's either going to be even or it's going to be odd. And then I like to look at the leading coefficient, and that's going to be the coefficient that's multiplied by your variable. You're going to be your constant, and that's either going to be positive or negative. Okay, so the important thing is we want to identify what is happening with these polynomials. Now, there's a lot of different ways depending on your class. You know, it could be like fall left, falls right, and obviously when we get into pre-calculus, we start talking about the graph approaching, and then when you get into calculus, you're looking at using limit notation. So I'm not sure what notation you need to use in your class, but here's something that I just remember. If you have an even and a positive, the end behavior is going to follow that simply of a quadratic. Rise left, rise right. If it's negative, then we know that it opens down. And students usually, once they've studied quadratic, they kind of remember like the opening up, the opening down, right? So that's what happens with the even. It doesn't matter if it's x squared, x to the 4th, x to the 22nd. They all are going to have the same end behavior when they are even, positive, or negative leading coefficient. For odd, it's just like a line. Like it falls left, rises right. So as long as it's, x to the 1st, x to the 3rd, x to the 17th, it's going to have the same end behavior and therefore the same for the negative. All right, guys, I am only got about 6 more minutes left. I do apologize for those of you guys that have joined in for the live stream, and I didn't get to your questions. I know there's like a whole bunch of them that I am just not going to get to, and so I really do apologize for you guys, but I will do my best to try to incorporate a couple more of these streams for you, so therefore I can help you guys out. But, it'd just be really helpful next time to have like the set of questions before, because obviously I just got bombarded and I was not planning on it, and I don't have anybody really to help me gather questions, but I don't have time to finish all the questions either. So, all right, let's just do these last 2 questions here as far as graphing and plotting the points. So graph the points 2x plus y equals 4. All right, so graph 2x plus y is equal to 4. Okay, so I believe the student was asking like to graph this, but also to find the points. Well, again, like this represents a line. Remember, a line is a set of infinite many points. So there's infinite many points that make up this line. So what we can really do, and I know students like have trouble with it, is we can just pick points. Like we can pick any point that we want to. A line has is not restricted on its domain. Like we can pick any number we want for x, and we're going to get some value for y. Now that doesn't work for all functions, but for a linear equation, like that works. So, typically what we like to do is, pick some very common kind of numbers, like for instance, -2. So to figure out what negative 2 is, so when x equals negative 2, we just plug in negative 2 in for x and then solve for y. So 2 times negative 2 is a negative 4, plus y is equal to 4, and then I add 4, and I get y is equal to 8. So when x equals negative 2, y equals 8. Now let's go and graph this. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. I plot the point. Then we could do negative 1. So you say y equals, 2 times negative 1 plus y is equal to 4. Well, now that's negative 2 plus y is equal to 4. And then you could say y is equal to 6 as you add 2 to both sides. I'll just show my work. All right, so now at negative 1, we have 1, 2, 3, 4, 5, 6. Okay. Now, hopefully you can kind of see that there's a pattern going on here, right? The distance from here to here is down 2 over 1. Let's see if that kind of continues. So let's do 0. So if I have 2 times 0 plus y is equal to 4, therefore I get y is equal to 4. So at 0, I get 1, 2, 3, 4. So in this case, I mean, I can find as many points as I want to. Like, it doesn't matter what points I pick, but hopefully you can recognize this pattern down 2 over 1, right? Down 2 over 1. So if I just wanted to draw a line, I know I'm going to need to go down 2 over 1 to give me my next point, right? And I can just continue this pattern to draw my graph, because that's the nice thing about having a line is that linear relationship. So once you kind of have 2 points, you can actually draw the graph of the line. All right, and the last one here is find the zeros for this. Now, we kind of talked about this here, finding the zeros, like setting the quadratic equal to 0. So I'm going to kind of work from here, because when we have a function, right, and again, we have this product. Now, this one's already in factored form. So when you have something in factored form, you're trying to solve it, just set it equal to 0. And now what we can do is apply the zero product property. So the zero product property doesn't just work for A and B, for 2 terms. It can multiply for multiple terms. Like, you can have infinite many terms multiplied to give you 0. One of those has to equal 0. So you could set these all equal to 0. Now, the important thing is when you set 3 equal to 0, like 3 equals 0, that doesn't make any sense, right? So therefore, that only works, you're only solving for the 0 when there's a variable. So the way to kind of get rid of this 3, or to understand, you can just divide by 3 on both sides. And we divide by 3 on both sides, that gets rid of the 3. And therefore, you can, if you set each one of these equal to 0 to save time, because I'm already kind of past my time, you'd have negative 2, positive 3, and negative 5. And that would be the solution set for you. So there you go, ladies and gentlemen. That has been about 45 minutes here for the stream. I do appreciate all of you guys joining in, and I really, really do appreciate. I was kind of taken back by how many students that would have the questions on the open stream, because again, like typically when I do these live streams for my own students, I don't get that many questions. So I need to come up with a different way for you guys to submit some questions and for me to help you guys out. I would like to continue doing more of these live streams. So obviously by you guys, staying active in the channel and showing up for the live streams and let me know what questions you have is obviously going to keep this running along. But otherwise, I am going to have to end this stream, so I do apologize for getting you guys out of see. If you're just saying I hate pre-calc, and it's like, yeah, I know. It's a lot of work. I get it, man. And it's a lot to understand too. So, but there's a lot of great questions in here. And I apologize, guys, for not being able to get to all of them. It makes me sad. I wish I could help you guys out, but I also know that it is literally impossible for me to answer every question, especially the more people that show up. It's just not going to work. So, but either way, guys, I got to do the best I can do to help you guys out. Even though you're not my children or my students, I always treat you guys like my students in there, because you guys are the ones that are showing up, and I'm here for help. So, unfortunately, guys, I'm going to end the stream. Actually, next week I'm going to be taking off. I'm on spring break, so I'll be out of commission for the math tutorials. So we'll take a week off. I do apologize if you have some stuff coming up there, but I got pre-recorded videos going on all the time. But then after a week, guys, we will get back into our instruction. So I'll look forward to hanging out with you guys then. All right, guys. I will sign off to you now. Cheers.